weird, looks weird, sounds weird, whatever, please let me know. This is my first day using Teams, so if something goes funky, it happens, but I'm still figuring it out. So, oh. Is that better? I didn't realize you could see that thing. No one in my first grade said that. Okay, cool. Didn't know that you guys could see that piece. Love that. I was going to yoink that. There we go. I was moving that off to the other screen. See, y'all showing me stuff. Awesome. You'd think it would block its own pop-up windows from blocking things. Weird. Microsoft is fun. We love this. The bestest ever. All right, so these two phrases are going to be super important for us. If we have something that has a direct relationship, that means they're on opposite sides of the equal sign, but on the same level. K is just some random constant. We will sometimes find K, sometimes we're just going to put K. A lot of times we're going to find K because they'll give us information, but we're going to start with just setting up the relationships. So when it's directly proportional, it's they are on the same level. If they are inversely proportional, my y and my x are on different levels. So the x would be in the denominator. So if it's inversely, it is basically as a fraction. So these two pieces are really, really, really the basis of what 4.6 is about. That's what those are about. So we're going to be given statements that say express this as a formula and then find K. That is what the instructions for almost everything in 4.6's homework say. So I'm going to give us several statements like that. You don't necessarily need to write the instructions paragraph at the top because it says a gigantic amount of things. It's just write it as an equation, then find K. So what it says is, like, I wasn't kidding. That's the instructions that come out of the book. It says express the statement as a formula that involves the given variables and a constant proportionally K, and then determine the value of K from the given condition. Blech. That's a lot of words. So what we have here is that U is directly proportional to V. Directly proportional means they're on the same level. So U is directly proportional to V means that is U equals some constant K times V. That's what that says. So that would be our formula, our initial formula. What they do is then they give us values for V and for U so that we can find K. So if V equals 30, U equals 12. So what we do is we substitute that in. We know U is 12 when K is times 30. So I don't really know what K is, but whatever it is times 30 will give us 12. So to find out what K is, well, solve for K. Divide both sides by 30. And we're going to get that K equals 12 over 30. Well, that simplifies down to 2/5 because those both divide by 6. There we go. My brain stopped there for a second. 12 divided by 6 is 2. 30 divided by 6 is 5. So our K equals 2/5. Therefore, our formula for the whole thing, wrong button. There we go, is U equals 2/5 V. So this is our initial proportion, the value of K, and our final equation. So there's three pieces we're looking for here. Our initial setup, K, equation. Those are the pieces we need. Okay? Questions on that bit? Okay, so let's look at the second one. It's very, very similar. What's from the right page? So we've got that R varies directly as S and inversely as T. So it's going to start mushing them together. So R, that's kind of the star of our show. R varies. There's going to be some constant K. So it's directly to S, so we know that's on the same level. So S, and inversely as T. That means T is going to be on a different level. It's going to be below. So it's inversely as T, which means we divide by T, and directly as S, so S is on top. So it smushes them together. So we're going to have times when that happens. Then they give us values for S, T, and R so that we can find K. And that's exactly what we're doing, is we're just going to substitute them in. I'm going to have my S is -2, my T is 4, and my R is 7. So my R, so we're going to have 7 equals K times that S of -2 over our T of 4. We can simplify. -2 over 4, we're going to wind up with 7 equals K times -1/2, that simplifies, or -1/2 K. You don't have to simplify there. There's lots of different pathways through. You could just multiply by 4 and then divide by -2. Totally valid. Or you can realize this is going to be the same thing as multiplying by -2. So we're going to have -14 equals K. So our final statement, our whole equation, is going to be R equals -14 S over T, or -14S divided by T. I don't care how you structure it. It really does not matter as long as the S and T are in the relationship that they are right here. So, okay, cool. Okay. We're going to practice a couple more of these. They're just weird, but they're not super complicated. I'm going to double check my time real quick. Oh, we're doing great. We're great on time. Okay. So, similar. We are directly proportional to the square of x and inversely proportional to the cube of z. So it's a little more complicated, but it's the same process. Yes, this will be on the unit test. There are some questions like this on the review that you guys took home in the packet. So yes, this is still a part of Unit 4. We will also go through this tomorrow if you want to. But like 4.6 is still a part of the chapter. So the relationships don't change. Like, we're not going to get more relationships. They don't get more complicated. It's just that our pieces here are a little bit busier. So what we have is we have that our y is, so we know it's going to be a y equals. And then it's always going to have a k, some constant k. We've got that it's directly to the square of x. So x squared, same level. Inversely proportional to the cube of z. Inverse means it's going to be in the denominator. So we're going to have it inversely proportional to z cubed. So it's the same kind of style, same pieces. We just have to put them in the relationship. Oh, my screen changed. Love that. So much fun. Okay, so then what we do is we have the information to the side. I've got that my x equals 5, my z equals 3, and my y equals 25. So we're going to substitute those in. So I've got that 25 equals k. That's what we want to find. My x is 5 squared. And we're over our z, which is 3 cubed. So we can simplify this. I'm going to have my 25 equals k. times 5 squared gives me 25. 3 cubed, 27. So when I divide both sides by 25 over 27, or multiply by 27 over 25, multiply by the reciprocal, solve for k, or multiply both sides by 27, and then divide by the 25. Why is it squared and cubed? Is question in the chat. Is we've got the square of x, it was written right here. That's why it was x squared. And we've got the cube of z. That's why they were squared and why they were cubed. So our k is actually going to equal, when I multiply this out, our k is going to equal 27. So our equation, our final answer, we're going to have our y equals 27 x squared over z cubed. So we've got our initial proportion, we solved for k, and we got our final equation. Okay. So they're going to toss in weird pieces like that sometimes, the squaring and the cubing. We just have to be careful. So let's do the bottom one. Same vibe. I've got that z is directly proportional to the product of the square of x and the cube of y. So same pieces, just different relationships here. I've got my, I'm going to change my colors real quick, just to keep things separated. So what we're going to have is we're going to have that our, there we go, z is, that means it's going to be a z equals, so z equals some constant k. We are going to be living in the world of the directly proportional. The product just means we're going to multiply the two pieces together. So the directly proportional, they're going to be on the same level. The square of x, so x squared, and the cube of y. So we've got y cubed. This product piece just means those guys are multiplied, the product. So just be careful with the setup. The setup is honestly the most important part of these. So then we're going to substitute in those values. I've got that my z is 16, my y is -2, and my x is a +7. And we're going to substitute those in. So we've got my z of 16 equals some constant k. We don't know which one yet. I've got my 7 squared and my -2 cubed. And we're going to simplify things. I've got my 16 equals k. My 7 squared gives us 49. And my 2 cubed gives us -8. So when we solve for k, we're going to take our 16 divided by 49 times -8. And we're going to get 2 over -98. Yeah, which will simplify down. I type things in wrong. I love it so much when I do that. We should get, 16 over our 49 times negative 8 is 392. But that'll simplify down, and you can do that in the calculator. Like, we have the technology. Our k is actually going to equal negative 1/6, according to my calculator. Nope. I typed things in wrong again. I'm so good at that. 8 over 49. That makes way more sense. I'm like, what's happening here? Minus 8 over 49. No, gosh, what is going on with me, guys? My brain is totally gooey. I am typing things in the calculator repeatedly wrong. 2 over 49. One of those mornings. Oh my gosh. So that K was a beast to wrestle with, but we got there in the end. Just be careful and type things in and pay attention, and it's really hard to talk and write numbers at the same time. So then putting it back into our original statement, we're going to have our z equals, I'm just writing it over here because I'm out of space on the right, our negative 2 over 49, that k can be gross like this, x squared y cubed. So just be careful on these steps. Make sure we're typing things in carefully, and try not to let your brain go full zombie mode when you're doing so. Questions on either of these two, especially with the chaos that happened with our k there? Okay, let me double check our time real quick. We've got about 5 minutes. So, I'm going to show you another way things sometimes are worded in the book. They sometimes will word it just like this and give it to you as 2 questions, but it's the same kind of thing where they say in the instructions what the relationship is. We've got z directly proportional to the square root of x, inversely proportional to the cube of y. We're going to express as a statement and find k, and then we're asked to evaluate, I think. Nope. Just write the equation and find k. So it's the same kind of deal. Sometimes they'll give you more values to substitute in and find like z after you've given the thing. But we're going to just do this one real fast. This will be our last one. So we've got, in our relationship here, I've got that z is directly proportional. So that means we're going to start with the z equals the constant of some value. And we are directly proportional to the square root of x. So we're going to have the square root of x here. And we are going to be inversely proportional to the cube of y. So inversely means it's going to go underneath y cubed. So then we're going to be finding our exact value of k, substituting in the pieces. I've got my x equals 36, my y equals 2, and my z equals 5. And we're going to just substitute those in. And I put the y as the wrong color right there because my y is green. There we go. So if we substitute those in, we're going to have our 5 for our z equals whatever our constant k is, the square root of our x, which is 36, over our y, which is 2. So we're going to have our 2 cubed. So we're going to have our 5 equals k. Square root of 36 is 6. 2 cubed is 8. Solve for k however you wish. Multiply both sides by 8. Simplify your fraction first. If you multiply by 8, you wind up with 40 equals 6k. So we're going to have a 40 over 6 as our initial option if we don't simplify. And then we're going to come through and simplify. Those are both even numbers. They both divide by 2. So our K is going to be 20 over 3. So our exact equation, we're going to have our Z equals 20 over 3 square root of x y cubed. So we can write it just like that. You can put that as a product. You can have them as two separate fractions multiplying against each other. There's lots of different ways to write them, but it's all about finding those relationships in there. And they just tend to throw some weirdo pieces at you with things being cubed or rooted in some strange way. So it's not super duper complicated. It's just strange interactions. So watch out for when we are directly. Directly means they're on the same line. They're both in the top. If it's inversely, that second piece is in the denominator. There's going to be pieces where we have more than one chunk. And we're just looking at the relationships between them, trying to evaluate and figure out the relationships between. Okay, I'm going to put up the page that has the information. That's the piece we're working on. 4.6, that's the last piece in this chapter. That is everything in there. I don't need to add anything tomorrow. We can work through some questions tomorrow as needed if you want to, or you can just work on the review, whatever we need to do. Anthony, did you have a question?
No, that was an accident.
No worries, totally get it, but I just wanted to check. So, technically, that is the end of third period. Homework 6, it's not super long, and that's not because they're tricky, it's because I knew this would be short. So, it is not super long. Even with showing my work, it took me less than 2 pages for the answers. So work on stuff, ask questions. We can go through some of these tomorrow if you want to. We can just work on the review tomorrow. But we've got chapter tests coming up on Friday. Okay, so scooch to fourth period. Do what you need to do. And I will see you guys tomorrow.